All right. Okay. Let's look at what we are here for. All right. All right. All right. Okay. Okay. Yeah. Hello everyone. Welcome to Ferdinand tutorials. So in this video, I want to start as much as possible to look at physics. In this interaction today, so we'll be focusing more on our physics. And in this topic, we'll be looking at, let's start with electric field. So we'll be looking at electric field. Are we there now? Electric what? Electric field. And under this electric field, we'll be looking at Coulombs law. We'll look at the concept of electric field and electric field intensity, and then we'll also look at what? Electric field potentials. So those are some important concepts that we'll try as much as possible to look at, first of all, before we move into other things. Are we together? I believe you can hear me, right? All right. Okay, so be that as it may, now what we're going to do here is that we look at, what we mean by electric field already. Without wasting our time, electric field is already a region of space. Are we there now? Where electric, charge, takes place, right? Now, any region, any particular area, are we there now? Where there is, electric charge, where there is electric interactions, wherever it takes place, we call that particular field what? An electric field. Are we there now? So we say that is where a charged body experiences an electric force. Now, first of all, I want to explain what we mean by Coulombs law. Generally, in Coulombs law, we say that Coulombs law, Coulombs law, mathematically, we're saying that force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Or we then we say electric force F is directly proportional to the what? Two charges Q1 and Q2 and inversely proportional to the what? The square of the distance. This is Coulomb's law. So this proportionality sign is the same thing as what? K will replace this proportionality sign with K. So it will be KQ1, Q2 all over what? All over R square. Are we together now? So in this scenario, we're going to say that F is equal to KQ1, Q2 all over what? All over R square. You get what I'm saying? So in a nutshell, we're going to say that Coulomb's law, we say electrostatic force or electric force, let's use the word electric force is equal to KQ1, Q2 all over what? All over R square, where K is the constant. Now this particular K, a constant, is given as K is equal to 1 over 4 pi epsilon naught. Are we there now? This epsilon naught is called, this is E naught. E naught. It's not like normal E, but E naught. We'll call this E naught permittivity of free space. E naught is equal to permittivity of what? Of free space. Of free space. So this is typically, equations of Coulomb's law. Now, most of the time they can ask you, say, okay, calculate the force, and then they'll give you two charges. Q1 and Q2 are, two charges, charge 1 and charge 2. R is the distance. Are we together now? So in a nutshell, what we are saying is here, if I have F equals KQ1, Q2, now K is a constant, which is 9.0 times 10 raised to power what? 9 is a constant. So whenever I want to solve a question that involves, Coulomb's law equation, this is, the particular formula or equation I'm going to use. Now, in most cases, they can say force of attraction and repulsion. They can either say force of attraction or repulsion. They say calculate the force of attraction or calculate the force of what? Repulsion. Now, remember that when we're talking about attraction and repulsion, in attraction arises as a result of what? Unlike charges. And that's why we say unlike charges does what? Attract, like plus and what? And minus. These are attraction. Now when we're talking about repulsion, we're talking about either plus and plus or minus and what? And minus. Those are like charges. So like charges does what? They repel. And unlike charges does what? They attract. Are you following what we're saying here? Okay, so now this is a Coulombs law equation. Now most of the time we can try as much as possible to solve a question example. Let's look at this particular example that I have here in my book. Okay, now look at this particular example. Now they say find the force of repulsion. Find the force of repulsion between two protons. Now they give us two protons. They say calculate the force of repulsion. I've told you when we're talking about force of repulsion, we're talking about they must have the same charge. Are we there now? So when they ask you for force of repulsion, it's still the same formula. But force of repulsion, they are trying to tell us that those charges, these are charges Q1 and Q2, they must be alike. When we say force of attraction, they are two dissimilar charges. So they can ask, say find the force of repulsion between, they give two protons, 1.6 times 10 raised to power minus 19 coulomb. Are we there now? 1.6 times 10 raised to power what? Minus 19 coulomb each. If the distance between them, this is Q1 and Q2. This is my Q1. Q2 is also this 1.6 times 10 raised to power minus 19 coulomb. Now they say if the distance is R. R between them is what? 5.3 times 10 raised to power minus 11 meter. Now they gave me, say take K is equal to this. Now this is a constant of K. We're not going to change it. Are we there now? This is what? A constant of what? Of K. Are we there now? So most times you might not see this K, you see 1 over 4 pi epsilon naught. So if they say take 1 over 4 pi epsilon naught equals 9.0 times 10 raised to power Newton per meter square per coulomb square, it's still the same thing that we're talking about in this scenario. I don't know if you're following me. So what we're doing here now is I'm going to say, okay, I've already gotten my question. So I'll say F is equal to, anywhere I see K, what am I putting? I'm going to put 9.0 times 10 raised to power 9. Because it's a constant, you must know it. 9.0 times 10 raised to power 9 Newton per meter square per coulomb square. So this is K times, now anywhere I see Q1, what am I putting? Q1, I'll put 1.6 times 10 raised to power minus 19 times also Q2 1.6 times 10 raised to power minus 19 all over. Anyway, I see R, what am I putting? The distance, which is 5.3 times 10 raised to power minus 11 all squared. Are we together now? So in a nutshell, I'm going to say F will now be equal to, I will bring out the whole number separate, because when you're solving this particular question in the exam, they might not give you scientific calculator. So I'll just tell you the simpler way to solve so that you can use all those crayfish calculator to solve and still get an answer. So I'm going to say F is equal to, now I'll bring out the whole number separate. 9.0 times 1.6 times 1.6 all over, I'll do 5.3 all squared. Are we there now? So I'll bring in my standard form. Remember, 5.3 all squared, when we get this, is 10 raised to power minus 22. Are we there now? So what I'm going to do here now, I'm going to say times everything up here is times 10 raised to power minus 19 minus 19. Are we there now? So I'm going to say F is equal to 9.0 times 1.6 times 1.6 all over 5.3 all squared. Remember, when we have a standard form, negative goes up, it will turn to positive. So I will have times 10 raised to power minus 19 plus 22. At the end of the day, I will solve to get my F. My F must be in what? In Newton. I will use your calculator and then you punch. Your force must be what? In Newton. That is the force of what? Force of repulsion. Repulsion is when we have same charges. Are we there now? When we have same charges, like if it's plus or plus, it is repulsion. Are we there now? If it's plus or minus, say for instance, they ask you, say, calculate the force of attraction between, they give you Q1 as minus 60 coulomb, and they give you Q2 as plus 90 coulomb. For you to calculate the force is going to be force of what? Force of attraction, because you have Q1, which is minus, and Q2, which is what? Plus 90 coulomb. Are we there now? So these are the formula on how to solve for Coulomb's law and force of attraction and what? And repulsion. Are we together now? Okay, now let's look at electric field intensity. Electric field intensity. I don't know if you have any question here. You can also let me know in the comment box. Now let's look at electric field intensity. Electric field intensity. Now, for electric field intensity, we're using the following formula. E is equal to F all over what? All over Q. That's the formula for what? Electric field intensity. That means, so far as, let's take for instance, they ask us to find this force, and then they say continuation, solve for electric field intensity. We're going to use the force all over what? All over the Q. But most times, they might not ask you to solve force. They will just ask you to solve for electric field intensity. Now, what are you going to do? You're also going to say E is equal to, anywhere you see F, what are you putting? KQ1, Q2 all over R squared. And what is K? 1 over 4 pi epsilon naught. So you can say F is equal to KQ1, Q2 over R squared, or you say F is equal to, anyway you see K, what will you put? 1 over 4 pi epsilon naught times Q1, Q2 over what? Over R squared. It's still the same thing, because this 1 over 4 pi epsilon naught is just my K. Are we there now? So every other thing is KQ1, Q2 over R squared. It's still the same thing. Are we there now? So generally, in most cases, they usually use this particular one to be easier. Are we there now? Now we're going to say E will be what? Anyway, I see F, I will put 1 over 4 pi epsilon naught. So I can say 1 over 4 pi epsilon naught times Q1 times Q2 all over R squared, are we there now? All over times Q. So I'm going to say E will be equal to 1Q, cancel 1Q here. So I'm going to say E will be equal to 1 over 4 pi epsilon naught times Q all over R squared, which is the same thing as Q times 1 is Q, which is the same thing as Q all over 4 pi epsilon naught R squared. Are we there now? That is, the formula for electric field intensity. If you don't want to do it this way, you can also say E will be equal to, anyway, you see 1 over 4 pi epsilon naught, you just put K. E will be equal to K Q over what? R squared. It's still the same thing as what? Electric field intensity. This is the formula for electric field intensity. Electric field intensity is equal to F over Q. F, anywhere you see F is KQ1, Q2 over R squared. Anywhere you see K is 1 over 4 pi epsilon naught. And then we input it and we continue to solve, and then we get this particular one, E, which is electric field intensity. Okay, let's continue. Let's solve maybe a small example in electric field intensity. All right. Okay. Now look at this particular example. Look at this example that they gave us here. Look at this example. They said, calculate electric field intensity. Okay, they say calculate the electric field intensity. And let me get a better question. Calculate the electric field intensity in a vacuum at a distance of 10 cm from a charge of 5 times 10 raised to the power minus 4 coulomb. Now, let's look at this example 1 in electric field intensity, E1. So they say calculate electric field intensity, calculate electric field intensity, EFI. How do you know? Calculate electric field intensity in a vacuum at a distance. They give us distance. Remember, in this particular, electric field, whenever we talk about distance is just R. So I'm going to say R is equal to 10 cm. Are we together now? Now, from a charge of, now they give us Q. What is the value of Q? Q is what? 5 times 10 raised to power minus 4 coulomb. Are we there now? Now remember, I told you that electric field intensity E is equal to what? F over what? F over Q. Are we there now? Am I right? Now in this scenario, I've already told you that whenever you see your F is KQ1, Q2 over what? Over R squared. But in this scenario now, we're going to have KQ1 Q2 over R squared times Q. 1Q cancel 1Q. So I'm going to have electric field intensity is equal to KQ over what? R squared. Or I'll say E is equal to, anyway I see K, I'll put 1 over 4 pi epsilon naught. 1 over 4 pi epsilon naught times Q over R squared, which is equal to Q over 4 pi epsilon naught R squared. Are we there now? This is still the same thing. Are we together? This is still what? The same thing. Electric field intensity, electric field intensity. Anyone I want to use, I will use. It's still the same formula. So in this scenario now, what we're going to do is we're going to say, anywhere we see E, what are we going to put? We use KQ over R squared. Are we there now? Now remember that they gave us Q, they gave us R. Now in this scenario now, this R here is in cm, is in cm. So I'm going to convert to meter. So converting to meter, I will use, because whenever we're solving questions on electric field, Coulombs law, electric field intensity, electric field potential, our R is always in what? Is in meter, unless in the option they are giving you otherwise. If the option you are being given otherwise, then we're going to use what is being given in the question. So, but if they didn't give you any otherwise, or exceptional, cases or scenarios, generally what we're going to use is that we're going to convert our cm to meter. So here now we're going to say E is equal to KQ over R squared, and cm to meter is 10 over 100, which is what? 0.1 meter. Are we there now? Converting to cm to meter, you divide by 100. If I give you 5 cm, I ask you to convert to meter, it's 5 over 100. Are we there now? If I give you 100 cm, I ask you to convert to meter, it is 100 over 100, which is what? 1 meter. Alright, so in this scenario now, we're going to put, anywhere we see K, what are we putting? Remember that constant, 9.0 times 10 raised to the power 9. Are we there now? Anywhere you see Q, what are we putting? 5 times 10 raised to the power minus 4 all over. Anywhere we see R, what are we putting? 0.1 all squared. So what we are going to do here, 0.1 all squared is same thing as 1.0, times 10 raised to the power what? Times 10 raised to the power minus 1. Are we there now? So I can say E is equal to 9.0 times 5 all over 0.1 all squared times 10 raised to the power 9 minus 4, 9 minus 4. And then you say E, electric field intensity, is equal to 9 times 4, that should be 45, right? Am I right? So that should be 45 times 10 raised to the power 9 minus 4 is 5 times 10 raised to the power 5 all over 0.1 all squared. Anything you get, that is your what? Electric field intensity. Are we together now? That is your what? Electric field intensity. Now the unit of electric field intensity is usually, remember, look at the formula for electric field intensity, F all over Q. What is the unit of F? If we say that electric field intensity E is equal to F over Q, what is the unit of F? F is Newton. Newton all over. What is the unit of Q? Coulomb. So electric field intensity is equal to what? Newton per coulomb. Are we there now? So here, anything I get, it must be in Newton per coulomb as my answer. So whenever you are seeing any question, and then this is, the unit of the answers you are seeing in the option, just quickly know that you're talking about force over charge, as simple as ABC. Are we there now? F over Q, electric field intensity, F over Q. Are we there now? So you have a lot of brain work to do than just the calculation. Do you understand? So you need to even understand, what am I solving for you to actually solve whatever you're solving for, right? Okay, so we've solved those questions. You can also look for other questions, in past question on electric field intensity. Okay, let's look at electric field potential. Now, in electric field potential, we usually use the formula for electric field potential, E electric field potential. We use the formula V is equal to W over Q. Are we there now? V is equal to what? W over Q. And whenever we're talking about W, remember that W is equal to force times what? Force times distance all over Q. That is to say, anywhere I see V, V is the same thing as F times D all over Q. And remember, F in Coulombs law, F is equal to KQ1 Q2 over R squared. Are we there now? Times, anywhere I see D, what will I put? R. Are we there now? All over Q. So I'm going to say electric field potential is the same thing as KQ1, 1Q cancel 1Q, 1R cancel R here. So I'm going to have KQ, I just have only 1Q remaining, all over, only 1R remaining. Are we there now? Because they've already cancelled each other. Are we together now? This is the formula for electric field what? Potential, which is also the same thing as anywhere I see K, I'll put 1 over 4 pi epsilon naught times Q all over what? All over R. Are we there now? So that my electric field potential is equal to V equals Q over 4 pi epsilon naught R. So this is the formula for electric field potential as well as what? As well as this. So anyone can go. Anyone can what? Go. I don't know if you're following what we're doing here. Okay. All right. Let's look at example. Let's look at example. They say calculate. I'll wipe this side. Now they said calculate the potential difference. If they don't say electric field potential, they say potential difference at a point 40 cm, from a charge of 3 times 10 raised to power minus 6 coulomb. Now, look at what happened. They said we should calculate the potential difference at a point 40 cm. They give us a point 40 cm. Whenever we're talking about 40 cm, we're talking about distance. So they give us R as what? 40 cm. And then they say a charge, which is Q. A charge of what? A charge of 3 times 10 raised to power minus 6 coulomb. Are we there now? Now, they didn't give us, any particular K. But rather they said take Q, take K, they said take 1 over 4 pi epsilon naught equals 9.0 times 10 raised to power 9 Newton per meter square per coulomb square. Are we there now? Newton per meter square per coulomb what? Square. So in this scenario now, what we're going to do here is that we're going to use the formula. V is equal to Q over 4 pi epsilon naught over R, or V equal to KQ over R. It's still the same thing. So if I'm using this particular V, I'll say V is equal to, anywhere I see K, what will I put? 9.0 times 10 raised to power 9. Anywhere I see Q, what will I put? 3 times 10 raised to power minus 6. I will do now all over. Anywhere I see R, what will I put here? This is 40 cm. I told you that we'll convert to meter. So I will say 40 cm to meter is 40 over 100. I will do now 0 cancel 0 into one place. So this is the same thing as 0.4 all squared. I will do now. So I'm going to say V is equal to 9.0 times 3 all over 0.4 all squared times 10 raised to power. Now we say 9 minus 6. I will do now. Anything I get in this scenario, what am I going to put? I will get, that will be my answer. Anything I get and then divide, that is going to be what? My answer. I will do now. Electric field potential is usually in voltage. Electric field potential is usually what? In voltage. Are we together now? Okay. So that is that. My answer must be in what? In volts. That's my electric field potential. So you can solve other questions, or if you have anyone you're having issues on, you can let me know. So now that is that. I want us to look at enter into electric current. I want us to enter into electric current. So just go through it and know if you have any question. Use your calculator and punch and get an answer. Okay, now I want us to look at electric current. Let's solve 1 or 2 questions there and explain 1 or 2 things that needs to be explained. Okay, let's go. Okay, we're still talking about physics, example, in this scenario now, we're going to be looking at what? Electric current. Electric current. We're done with electric field, electric current. So any questions you see? Oh my God.